Hello, everybody. Welcome back to another Learning Godot gameplay. I don't know what I want to call it. Learning Godot live stream, where we're going to be continuing our journey trying to learn the Godot engine. So let me go ahead. I think I need to share another monitor just so you can see what I'm seeing for the tutorial. We're watching Brackeys, of course. We're going to continue watching Brackeys for a little while. While we try to develop our game that we want to make in Godot. So last time we left off, we were about halfway through and we're learning about pickups and stuff like that. So we're going to continue watching. And if I play, we kind of see what we have. We can jump, move, pick up the coins and stuff. There's no audio or anything. We're working with layers and all that good stuff. So that's where we're going to hopefully continue with here. So let's go ahead and continue watching. I'll go ahead and share the YouTube series if anyone else wants to watch.
Starts displaying the message, and will do so every time the platform passes through the area. To change this,
so I believe I did this part. We're just going to rewatch it just to double check because it's been a while since we did the Godot series.
Layer. Let's try that out. So under our player, we'll go to the inspector,
go
to collision, and here we can change the physics layer from layer 1 to 2. Let's hit Ctrl S to save. And then in our coin, we can also go under collision. We can actually...
So where did he go?
And here we can change the physics layer from layer 1 to 2.
Yeah, we got that.
Ctrl S to save. And then in our coin, we can also go under collision. We can actually have the coin itself stay on layer 1. We don't need a separate layer for that yet. But we want to make sure that it only detects colliders in layer 2. For this, we use the mask.
Masking, okay.
Defines what layers a node
so these things, like layers and masks, are kind of like a collision presets and channels and stuff like that in Unreal. It's just not labeled in any way.
And instead of just displaying a message, let's also remove the coin from our scene when we pick it up.
So I think that's what we did last time, because the coins do disappear. Whoops.
Let's add a new line. We'll call the queue_free function, which is simply going to remove the entire coin scene from our game.
I can't jump for shit.
It does. And our knight can now start gathering some coin. Now, depending on what type of loot we pick up, we want different things to happen. In this case, I want to display a score that increases when we pick up a coin. But we'll look at that when we get to text. First, I think something a bit more pressing is dying and restarting our game.
Yeah, dying and restarting will be interesting.
1.0. So we happily move along in our world until suddenly we miss a jump and fall into the abyss. And then nothing happens. Let's change that.
So I wonder how he's going to do this. Is he going to set up like an explicit kill zone object that if you overlap with, they'll die? Or is it going to be more of those things where you fall a certain wide depth and then you'll die? Kind of curious how he plans on handling that.
The first thing we want to do is limit our camera so that it doesn't follow our player when we fall down. Luckily, this is really easy to do. We simply select our camera under the player, go under limit, and here we can set a position limit for the left, top, right, and bottom part of the
interesting.
camera.
Okay.
In our case, we need to set a limit for the bottom position. To do this, we can use the ruler tool here at the top, or simply press R, and measure from this baseline here to where we would like the limit of our camera to be. I think a good value would be somewhere around, say, 120. So I'll simply go back to select mode and put in 120 pixels on the bottom.
Fair enough.
I'm also going to enable smoothing, and now when we play, we can see that our camera will follow the player, but whenever we fall off, it's simply going to stay put.
Interesting. Okay, let's check that out. That's fair. Okay, but it does follow you still on the X and Y. I guess we gotta stop camera movement when you reach that depth as well, maybe?
Next, we need to detect that our player has entered a dangerous area and restart the game. In other words, we need to create a kill zone.
Yeah, okay, so you gotta do a kill zone.
A cool way to do this that
easy enough.
To reuse the same kill zone for more than just falling off the map, such as for spike traps, enemies, all kinds of elements of danger. And when we want to create a reusable element, we start by making a scene.
Yeah, make it a
then
scene.
To detect if we enter an area, we again use the area 2D node. And let's make sure to set the collision mask here to 2. We only want to check for the player, which is on layer 2. And we won't add a collision shape here. That's because we want to be able to reuse this for all kinds of elements that might have different shapes. Instead, let's simply go ahead and rename this now to kill zone and save it as a new scene. Then in our game scene, we can add it by dragging it in or simply pressing the link button here and selecting the kill zone. And then in here, we'll add the collision shape. So I'm gonna hit Ctrl A, collision shape. And for the shape, we'll use the same world boundary shape that we used earlier for the ground. Now,
hold on. Add child. Can I say kill again? No. Oh, do I just drag and drop it? Okay, kill zone. Then we right click on it, add child node, collision, shape 2D. Then he does world boundary shape.
now let's make sure to select the kill zone node itself, go into move and use the move tool to position it down here at the bottom. I'm gonna place it pretty far down so we're sure we don't hit this by accident. Or I mean, we're gonna be hitting it by accident, so let's make sure we don't hit it on purpose.
Okay.
I don't know. Anyways, I'm gonna place it down here a good bit away from our level. And now we can add a script to make something happen when we enter the area. So in our kill zone, let's select it, add a new script. For the template here, I'm just gonna select empty, and the path, let's put it under the scripts folder. And now we have this empty script to play with. I'm gonna connect a signal, so go node, make sure we have the kill zone node selected. And again, we'll use the body entered signal. So let's double click it, hit connect, and it's going to create a...
Okay, hold the phone. Okay, now there's the signal, right? History node inspector. Whoops. Okay, here we go. And then he's saying on body entered. That should be good. Body entered right there. Perfect. Okay, we're Gucci.
On body entered, in which case we can go ahead and print that you
died.
And now if we play and jump down, it's going to print that we died. Now instead
All right, let's see if we get that as well. Game F6. So we have our console, right? So we have +1 coin. Now you died. Okay, great.
immediately restarting the game, let's add a small delay. We do this using another node called the timer node. So let's add a new node, search for timer, and under the inspector here, we can choose some different things about it. Let's set the wait time to something like 0.6 seconds. Let's also make it a one-shot to make sure that it doesn't loop. We can then start this timer in our code. To do that, however, we first need a reference to it. Luckily, that's as simple as going to the top of our code, clicking and dragging the timer node, and holding down Control while releasing. This creates a variable called timer that automatically finds the node using this path. Now, if you haven't worked with paths before, they are actually quite simple. They specify a way to get from one node to another in the tree. So if we look at this example tree, to get from the game node to the camera, the path looks like this. It goes through the player and ends with the camera. And in our case, where we just want to get from the kill zone to the timer right underneath, we don't have to go through any other nodes, so the path is simply timer. Again, right now we're brushing over concepts such as variables and functions pretty briefly, but you can learn more about programming and what all this really means in our upcoming video on GDScript. For now, just know that using this click and drag method, we can now access our timer node using the name timer. So to start our timer, we make a new line and write timer.start. Of course, we now need to trigger some code when our timer runs out. And again, we can use a signal for this. So with our timer node selected, let's go under node, and here's the timeout signal. So let's double click that and hit connect. And this creates a new function called onTimerTimeout that runs when the timer ends. And then in here, we can simply restart our game. To do this, we first access the scene tree, so get tree, and tell it to reload, so reload current scene. So our player enters the kill zone and triggers the on body.
So it just resets
function.
the scene. Yeah.
This prints a message that we died and starts the timer. When the timer runs out, it triggers the on timer timeout function, which
So
then
is that
reloads
actually
our
like
scene
enough?
and restarts the game. And indeed, when we play and jump off the map, we fall down and the scene restarts. Great.
That's pretty cool.
It's an infinite loop. Help me. I'm stuck. World building 2.0. Let's expand on our game world a bit now that we have more elements to work with. First of all, I want to make sure that we stay organized. So let's take some of these nodes and categorize them. The easiest way
so
to
he's
do
going to
this
make the
is by
level more
simply
complicated.
adding
I don't
a
know
new
if I
node.
care about making
For
the
this one, I'm
level
just
more
gonna select the
complicated at the
base
moment.
node here, hit create, and now we can rename this. I'll make one for, say, coins, and simply take all of the coins and drag them under that node. We can do the same thing for platforms.
Okay.
And any other elements that are cluttering up your scene. Now I'm going to paint in a bit more level and change the things that I don't like. And I'll put in some more gameplay elements. I'll also paint in some background tiles. But to do this, we need to add another layer to our tile map. So not under our tile set, but under the tile map itself, we have this layers. And this is the one we've been painting in. Let's just call this mid for midground and add another one that we can call background. Let's
that's cool. You can have layers on the tile map
to make sure that it's drawn first. And now when painting, we need to select the right layer to paint on.
Okay. Interesting. So it's physical layers. What's this under? So tile map layers. You can name it. There's background. Then he said he named this one midground. He called it mid, but I'm gonna call it midground just so it's clear what it is. Oh, hey, how you doing, Squeaky Knee? Yeah, I'm happy to just start learning Godot as well. It's good to just try to learn another engine outside of Unreal. So taking it slow, but all the concepts are the same. So I'm glad it's not entirely different. But also I'm trying to think in 2D space rather than 3D. So a lot of information and a lot of cool tools like the tile maps and stuff like that.
Let's select the background, and then we can start painting in some background tiles. A nice trick here is to use the rectangle tool to paint in a lot of tiles at once.
Okay, so he's drawing kind of like skies.
And now our game looks a lot better. It has a background and a whole new part of the level that we can explore. And of course, this process is just about trying things out and making changes until you're satisfied. Enemy.
That's cool, but I'm not going to do too much work on getting it organized and stuff like that. Oh, I appreciate the follow as well, Squeaky Knee. You're working on an isometric right now? Very, 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 very cool. So I'm guessing, is it 2.5D? Oh, and you subscribe. Oof. Very cool. Much appreciated. So I guess if it's isometric, it's 2.5D, or are you doing full 3D and just the camera angle is isometric, or is it just 2D with an isometric camera?
Since this enemy doesn't need to collide with
That'd be interesting.
anything, we can just go ahead and use a node 2D as the base.
All right,
Let's
so we gotta
also
do a new
add
scene.
an animated sprite. So I'll search for animated sprite 2D. Let's go to animation, add some new sprite frames. Select them, and let's load in from the sprite sheet here. In the pack, there's both a green and a purple version of the enemy. I'm just going to choose the green one, and this is a 4x3. And I've included...
All right, hold on. He's going by a little too fast. Give me a second here. So animation, sprite frames, new sprite frames, then down here. Then, what did he do?
I'm just going to choose the sprite sheet here, add some new sprite frames,
Yep.
select them, and let's load in from the sprite sheet here. In the pack, there's both a green and a purple version.
Hold on. What did you select?
And let's load in from the sprite sheet here. In the pack, there's both a green and a purple version of the enemy. I'm just going to choose the green one. And this is a 4x3. And I've included 3 animations here, one for the enemy kind of waking up, an aggressive idle animation, as well as one where the enemy takes damage. So I'll use the idle animation here. Let's add these 4 frames. Let's hit
Hold
F.
on. He's going by too fast again. How do I... Is there a way to zoom in on this? Ah, you gotta plus it. Okay. It's like 2.5D-ish. You fight enemies on top of rooftops and explore Cyberpunk City. Very, very cool. I'm guessing is it pixel art? I'm assuming it has to be, right? Or no, if it's 2.5D, then it's not pixel art. Sorry. I guess it has to be some sort of stylized, I assume.
I'm also idle animation here. Let's add these 4 frames. Let's hit F and zoom in. I'm also going to move this up, set the animation to autoplay and the FPS to 10. And now if we preview, we have an animated slime. And this is where things get really cool.
10.
Because we made our kill zone into a reusable scene, we can
Is this
simply use
autoplay?
it for our
No.
enemy as well. So
Autoplay is this one. Cool.
at the top here, I'll add in a new scene. I'm going to select the
Hold on. Scenes, player, okay, enemy, save, F6. Alright, he's in the corner. That's fine. How does he preview it though? Oh, it is pixel art. Cool.
use it for because we haven't added the animations. Let's hit F and zoom in. I'm also going to move this up, set the animation to autoplay and the FPS to 10. And now if we preview, we have an animated slime.
Oh, okay, you can preview in... Nope. Animation. Sprite frames? Yes. Okay, and there's preview like that. Okay.
Things get really cool. Because we made our kill zone into a reusable scene, we can simply use it for our enemy as well. So at the top here, I'll add in a new scene. I'm going to select the kill zone. And now all we need to do is give this a collider. So Control A, search for collision shape. Let's add in a rectangle, fit it to fit our enemy. By the way, I'm holding down Alt to scale uniformly. And with that, we can simply rename our top node here to slime and save it as a scene. Now in our game, we can drag it in.
All right, hold on. So transform. Oh, that's the problem. Okay. So transform. So 0.5 makes sense, and then, okay, no, it's locked. Hold on. Guess something like that is okay. More or less, I guess. I think that's... All right. I'll say that's fine. We don't want to focus too much on it.
I'm going to place it over here. And if we play now and move
so now, he puts them into the level. So let's add child node, just node, right? And then do enemies, more slime enemies. And then enemy. Yeah, we put him right here. And he plays. Huh? What? Wait. Why am I dying all the time? That's really bizarre.
the enemy, We can see that just by throwing together a couple of nodes and reusing our kill zone, we've successfully added a new element of danger to our game. If we enter the enemy, we can see that indeed our game restarts. Of course, currently dying doesn't look very exciting. We'll fix that in
So yeah, let's see what just happened there. Are your collision layers set up properly? I think so, based on what I did, unless I didn't. Oh yeah, you're probably right. So yeah, let's go back to the slime. Goes in shape. We gotta do. Is it this one? Visibility, texture, no. Kill zone. It's not visibility, is it? No, that's visibility layers. Closing shapes. Unless I do the kill zone thing. Collision. Yeah, we want to just do mask 2, I believe. So that should fix it. Good call on that. But let's just double check. Whoop, I gotta add the enemy again. So I'll add them here. Yeah, that's better. Let's see. Let's GG's and die. Yes. Awesome. Good call. All right, let's continue.
next chapter. But first, let's make our enemy move back and forth.
Nice.
We could, of course, do this using an animation player, just like we did for our platforms. However, I think it would be cooler to make a script that moves our enemy to the right until we get close to a wall, in which case it changes direction and starts moving left. This way we can simply drag and drop the enemy between any two walls in our game, and our script will do the rest. So let's start by making our enemy move to the right. So
I mean, that's kind of limiting. I guess it depends on when he's going to end up calling a wall. Because my level doesn't really, it has one wall. I guess technically it's like here and here. But it would be interesting if we're able to set it up so that he goes to like the edge of a path and then turns around as well. I think Mario has that. I don't know. I think Goombas keep walking, but Koopas are the ones that kind of go back and forth. But, you know, we're not doing Mario, so.
we'll go into the slime, add a new script, use the default template and place it under the scripts folder, and hit create. Let's get rid of the ready function, and instead we're going to be using process. Just like movies, video games display motion by drawing frames and showing them in quick succession. While movies show frames at a fixed rate, most often 24 frames per second, video games generally try to draw as many frames as possible to get a smooth result. How often this happens will depend on the system the game is running on and what is happening in the game. But unless the game is lagging, it should draw a new frame at least 60 times per second, and often much more. Before the computer can draw a new frame, however, it first has to update the state of the game. What has happened since the last frame? It does this for all the nodes in our game. Then it draws the new frame. This is referred to as the game loop, because it happens over and over again.
Over and over again.
Godot, of course, does this automatically, but we can add functionality to the game loop using the other function in the template, process. Unlike ready, which only runs once, process runs every frame. This makes it perfect for doing things over time, such as moving an enemy. We simply make sure to change the position of the enemy a tiny bit each frame. So in our script, we can simply remove the pass keyword and instead access the position of our slime, more specifically the x-coordinate of our position, and add 1 pixel to this every frame. Then in our game, let's go ahead and place a slime close to our player so that we can see this happening, and play. And as you can see, the enemy just shoots past us on the screen. Now, one problem with this...
I want to see what that looks like. I gotta put a slime in frame. Hold on. I'll move him down. Oh, slime. Doink. Slowly but surely, he's going. He's moving a little bit. Okay. So I guess 1 is not enough. I'm guessing his flew by because he didn't multiply by delta, and that's why he's doing plus equals 1. Yeah, so script. Typically, I guess you would want to have a var I know you don't have to explicitly declare in GDScript. It's like Python in that way, and I don't remember how you explicitly declare a type for a variable. I don't think it's like var float, speed or int. Like 50 or something. Is that right? Okay, so it's the, okay. So that's how you do it. So var speed int equals 50. I mean, yeah, I guess move speed will probably be a better variable name and, snake case, or whatever that case is called. And then, yeah, you would just do move speed. And yeah, I can't remember at the moment, but yeah, there is a way to make that variable public and accessible. I forget what the syntax is for that.
That might not.
There's no need to tell me. I can look it up. I know I did in one of the other examples, obviously, at some point. I can't remember. So GD script, public variable, I guess. It's not a global variable, but I'd like a public variable. Because, yeah, they're telling me static. GD script, variable. I think is it export? And then I go back into game, go to slime. Yeah, move speed. Yeah, it's export. And I know you can also put them into categories. Maybe this documentation will have it as well. Yeah, grouping it. So yeah, group export by properties. So you get to say like, movement properties or something. So then, yeah, if I go back into the game, yeah, movement properties, bam, it's all there. That's cool. I wonder if 50 is way too much. Yeah. But honestly, we're not going to care too much about how that looks at the moment. For now, default value, let's make it 20. And let's keep watching.
Be obvious, other than it's moving way too quickly.
Yeah, I gotta remember that syntax. Export and export group
by a fixed amount. And because our frame rate can vary, this means that the enemy will sometimes move faster than others, which is not very good. To fix this, we use this little thing here called delta. Delta is the amount of time that has gone by since the last frame. If we are drawing many frames per second, delta gets really small. And if we lag out a bit and are not drawing as many frames, delta becomes bigger. Because of this, we can use delta to compensate for variations in frame rate.
Delta Airlines.
If we have a high frame rate, we want to only move our enemy a little each frame. And if we have a low frame rate, we want to move it a lot. In other words, we can multiply our movement by delta to make it independent of the frame rate. Now, delta can be a bit hard to wrap your head around at first, but don't worry. You'll get the hang of it.
You can also make singleton scenes where it makes a scene constant across all scenes and accessible from root tree. I usually do it for the client scene.
Here, we should probably multiply.
I mean, when you say client, so are we talking multiplayer, like that kind of client? Or like what kind of singleton scenes would exist? Is it like a UI scene or something like that? I'm not sure.
We simply go plus equals 1 multiplied with delta. Now what this essentially means is that we are going to be moving 1 pixel per second.
UI works too?
Which is not very fast. So let's instead change this to something like 60. And we can actually store this speed in a constant at the
I swear to God, if he's going to do the same thing that I just did.
top of our script, just
That's
like
gonna
in
be
the
funny.
movement script. So here I'll write const speed and set it equal to 60. Then we can simply use
Okay, he's just
speed
making it
here
const.
instead of hard coding the value.
I guess is that like a what's the term? syntax. It's not a syntax thing, but like a style thing where if you make it a constant, it has to be all
This
uppercase
makes it
letters.
easy to change
Probably.
constants right at the top of your script. And now
I
if
handle
we
player
play,
settings that I don't want
we
to
can
attach
see
to the player
that
body in
our
case of
enemy
death.
is moving
Client.
at a
Okay.
reasonable rate, and we know that this speed
That makes
won't
sense too.
change from system to system. So let's get rid of this extra slime here, and instead make this one actually change direction whenever we face a wall. To do this, we need a way to control the direction we're currently moving in. So let's create a variable that does this. We'll create a var, call it direction, and set it equal to 1 by default. Then if we need to go in the opposite direction, we'll set it to -1 instead. And to actually apply this, all we need to do is multiply it into our speed. So we'll go direction times speed times delta. This is a really standard way of doing movement. We simply add onto our position in a direction, multiplied by speed and delta. So now all we need to do is check if the enemy gets close to a wall. And for this, we'll use a new type of node, the raycast node.
Okay, so
Raycasts
raycasts, that's exactly like line traces and stuff like that in Unreal. So that's probably going to be making a lot of sense what he's going to do. So I guess he's just going to be drawing forward. But I also would wonder if we would want to draw forward and draw down as well. And that would be able to handle the cases of like, because he's only going to be handling like when you're on a ground and walls are there, and he'll raycast once you hit a wall, and then once you hit a wall, he'll change direction. And I wonder if we want to do a couple things. We want to raycast forward, like a tile size, and if you hit something, obviously you hit a wall. If you didn't hit something, then maybe do a secondary trace downwards and see if you hit the ground. And if you don't hit the ground, that means you should also kind of change direction, knowing that there's no platform to go in next. Otherwise, you'll kind of fall off. Maybe we can try doing that. If he doesn't do it, I have to see what he actually kind of handles for this use case.
visible rays that we can shoot out to detect collisions. So
I wonder what the
inside of our
debug
slime
looks like
here,
for that as well, because Unreal, you have like these 3D drawn line traces, like red lines. You could change the colors and stuff. So I wonder what that looks like here too.
let's add a new node of type raycast2D, and as you can see, it draws an arrow to represent this. Let's move the starting point here to the center of our enemy, and let's have it shoot out to around here. I'm gonna rename this to...
Okay, so you define the raycast. I guess you could probably update the you could probably update the length, I suppose, in runtime. So that's interesting. Whoa. So it looks like that by default. Let me reset.
And let's an arrow to represent this. Let's move the starting point here to the center of our enemy, and let's have it shoot out to around here. I'm gonna rename this to raycast.
So I wonder, can you use the same raycast 2D node to run two separate raycasts? So you do a raycast node forward and then one down, like one after the other? Or do you have to have two separate raycasts, like nodes for that, like one that shoots in the forward X or whatever direction X, and then the Y? I wonder. But yeah, let's do one thing at a time. So we moved it down here. And then you moved it like here. So we'll do 20, I suppose. Now he's renaming it.
Cast right. I'm then gonna press Control D to duplicate. I'm gonna have this shoot out in the opposite direction.
Okay, so he is having separate, you can have multiple raycasts in one node and script out the handling. Okay. Because I'm curious why he's doing it this way. He's doing a raycast right and a raycast left. Maybe he'll explain. Oops. And I'll do -20.
And rename this to raycast left. Now in our script, we can reference these nodes just like we did with our timer. We simply select them both, click and drag, and hold down Control while releasing. As you can see, this creates two variables, one raycast right and a raycast left. Then every frame before we move our slime, we will go ahead and check if we are currently colliding
Probably doesn't want to get into vector math.
To the right
Fair.
or to the left. If raycast right dot is colliding, if this raycast is hitting something, well then colon, and then make sure to indent here with the tab. We will set our
No, you
direction
don't have the
to be
parentheses,
-1.
right?
If we are colliding on the right, we want to move to the left. And we'll add another one of these if statements. So if raycast, you guessed it, left dot is colliding, well then we'll set our direction back to 1. And that's it. Our enemy is now ping-ponging back and forth between the two walls.
Okay, hold on. If ray is left, that is lighting. Current direction equals 1. I gotta remember not to do. I always get into the habit of doing a semicolon at the end of a line, just because of C++. I just gotta get out of that habit. So let's add a guy here, and let's just see what that looks like, if that works. Okay, so it looks like it's working. Definitely too big of a recast, I'd assume, but seems to be working as he's intending here.
And this is happening completely automatically through script. Really cool. Now the only thing that is left is to flip the enemy sprite when it changes direction. Luckily, if we go inspect our animated sprite here, under offset, we have this flip age property, which will simply flip the sprite. So let's control this through our script. In our script, we'll get a reference to our animated sprite 2D. This creates a variable called animated sprite 2D. I'm just going to get rid of the 2D here to make the name a bit shorter. And then whenever we are colliding on the right here and we change direction to move towards the left, we will also go to our animated sprite and set the flip age property to true. And when we are colliding on the left and we're changing direction again, well then we'll go to our animated sprite and set flip age back to false. And that's it. That's our entire script. Let's find our enemy here and hooray! We've made an enemy. And a slimy one at that.
Let's see if that
but of
works.
course, dying to the enemy could definitely look cooler. So let's fix that. Dying
2.0.
2.0.
Okay. So yeah, this looks right. This flip. I will adjust the raycast size. Maybe 10 is okay. Yeah, that looks fine, I think. Cool.
Let's start by adding a slow motion effect when we die. We can do this
slow
by
motion.
changing the time scale of the entire game. So inside of our kill
So that's basically time dilation. So there's global time dilation. I wonder if there's a local time dilation as well. Let's see how he does it here.
We'll open up the script here. And right after we print you died, let's modify our time scale. So I'll go engine.timescale and set it equal to 0.5. This means that we will go at half speed. Then when our timer runs out, let's set this back to default, because otherwise we will actually still be slowed down when our scene reloads. So we'll go engine.timescale and set it back to the default 1. And if we play this now, this is actually already much better. Notice that it also takes twice as long before the game restarts, because everything in our game slows down.
I didn't really notice that. Let's see what it looks like when I die, and then I also like try to jump. Yeah, okay, I see it.
Including our timer. But I think it could be even cooler if we remove the player's collider to make him simply fall off the map. To do this, we need a reference to the player. We actually already have this here. You'll notice that after the onBody entered
So
here,
body,
there's a
right?
variable called body.
But
This refers
I'm assuming we would have to cast to the player, so I'm curious what that kind of looks like, how casting works. I wonder. Let me see, like body dot get no. No, I have no clue. I don't even have to guess on how to do it.
And since the only thing that enters the kill zone is our player, body is our player. So we can actually add a new line here that goes to our body. And then we simply need to get the collision shape node under our player. So we'll do dot get node, and we'll search for the collision shape 2D, and we can remove it. So call dot queue_free on that node. Again, queue_free means to remove that node. So here we're accessing our player, getting the collision shape node, and removing it.
And I guess because of the way we're resetting, we reload the current scene, this will be kind of re-added.
And now if
but I'm curious, search docs, cast, type conversion and casting. That's C#. Is that not a thing in GD script to be able to cast and get more information? You kind of have to do something like this? Or is there like a body dot? So there's a bunch of stuff that you have. There's raycasts. It doesn't seem like there is. I'm sure there must be something, right? But let's not focus on it.
If we find our way to some danger, boom, we are hit and we fall off the map. Cue the sound effect.
I wonder as well, is that the best way to handle that? I know, again, this is just examples that he's doing for the sake of brevity and everything like that. But would you want to, because queue_free just kind of deletes it? Like, would you not want to, I don't know, update the masks so that you kind of don't have the collision anymore? Let's see, do they want to do Mario style where, it pushes you up a little bit? What options do we have? We have collision shape player and stuff. What kind of thing is this? So type. Character body 2D. I wonder. If I say like body dot get node and then so character body 2D. And can I say like, is there like a velocity or something? I'm not sure how the best to handle that. Or is it just body dot velocity? I also don't know why like autofill is not working on it anymore.
Player 2.0. So far, we've been using the
I guess
character
we'll get over it.
template pretty much as is. But we need to modify it in order to add animation to our player, as well as change the key bindings that we use to move. So what are we looking at here? Well, the top two lines define two constants with our speed and jump velocity. There's also a variable here that defines the gravity based on our project settings. By default, this is a value of 980. So we have these three values, but the meat of the script is really inside of this physics process function. Physics process is very similar to the process function we used for our enemy. However, while process is great for a lot of things, there is one part of the game engine that really struggles with not knowing how many times per second it is going to be run. That is the physics engine. Physics in general need to update at fixed intervals to avoid janky behavior. Luckily, physics process solves this problem because it runs at a fixed rate, 60 times per second by default. This is independent of your game's actual frame rate and helps physics run smoothly. We use it for anything that involves the physics engine, like moving something that should collide with its environment, such as a...
And I guess that's kind of like the ticking groups in Unreal. You have different groups that it ticks at, but maybe it's not the same.
Player character. So in this function, a few things are happening. If the player is not standing on a surface, we add gravity. If we press the spacebar and the player is on a surface, we jump, and then we get the direction we need to move in based on what arrow keys are pressed and move accordingly. Now let's start.
I also forget the shortcut to see. Yeah, okay, lookup symbol is what it is. So yeah, is on floor. Return to the body collide with the floor on the last call. I mean, that's gonna be interesting. Like, it would be cool to see more about like how that works. But yeah, I won't stress on it at the moment.
By rebinding some input keys. For this, Godot uses an action system. We create actions for anything we want to do in the game. Jump is an action, so is move left or move right. We can then bind keys to these actions. Let's try it out. So let's go to Project, Project Settings, Input Map. And here we can add some actions. I'm gonna add a jump action, as well as a move left and a move right. Then we can use the...
I'm also kind of curious with these naming conventions, you know, it's all lowercase. Just, is that intended? So jump, and then move left, move right.
Plus sign over here to bind a key. So to my jump here, I'm gonna hit plus, and then it's listening for input. So
luckily it does that cool thing too. I recommend always lowercase. Okay.
Space is now bound to jump. For a move left, I'm gonna bind the left arrow key, and I'm also going to bind the A key. So we can use vast for movement as well. As you can see, there's no problem binding multiple keys to the same action, which is...
Yeah, it's kind of interesting. Like, I like this setup as well with this input map. I think Unreal has been doing that for a while, but something that's cool with the input mapping context and everything like that too is, you know, you can select, you know, the icon for the keyboard and know to tell it which key to kind of bind to, and it works in a similar way. So there's a lot of parallels here.
Really handy.
Because, like,
I'm also,
you know, just as the sake of an example, you know, I have a, hopefully it'll connect. Yeah, I have a gamepad, and, you know, I could do the plus sign, and I could just do left on the gamepad, and we get that as well. So that's pretty clutch.
we're going to bind right arrow to move right, as well as the D key. And now we can use these actions in our script. By default, Godot uses some built-in actions that are meant for navigating UI.
So I guess I could do
things like
left.
UI accept here. Let's replace these with our own actions instead. And as you can see, it will actually help us by auto-completing here. So I'm going to put in jump for my jump action.
So now I should be able, yeah. So now I can control
to move left, and for moving right, I'm going to change to move.
But yeah,
right.
I gotta
And now we
update
can use
the
keys
jump
bound
button
to
here.
our actions to move around, which in my case are both the
Hey.
fast keys and the arrow keys. Awesome. The next thing.
So now I should be able to play with the gamepad. I think that's pretty cash money. Because, you know, I prefer platformer games on a gamepad, honestly. So yeah, that's cool.
Thing we need to do is to update our player graphics to face the direction we are moving in, and to play the right animation. Let's start by flipping our sprite based on direction. So just like with our enemy, we first need a reference to the animated sprite node. Again, here we can simply click and drag and hold down Control. Again, I'm going to remove the 2D from the name to make it shorter, and then we'll add some extra code to our function. Now,
I know const should be towards the top, so I'm gonna just put it down here like that.
this line here defines a variable called direction that is based on our input. If we don't press any buttons, direction will be 0. If we press move right, direction will be 1. And if we press move left, direction becomes -1. So we can use this variable to check if we are moving left or right. I'm going to make some space in the code here and make my own comments as well. So use a hashtag for a comment. This here gets the input direction, which can either be -1, 0, or 1. And this down here actually applies the movement. So in between, we can add a section that flips the sprite. To do this, we check if our direction variable is greater than 0, well, that means we're moving to the right, and we can set animated sprite dot flip horizontally to false. If this is not the case, well, then we want to check if our direction is less than 0. For this, we can use the else if or elif keyword. So else if our direction is less than 0, well, then we'll set animated sprite dot flip age to true. And now if we play this, we can see that our player sprite indeed faces the right direction. Now let's add some animation. So let's go to 2D.
I wonder how you can also write tertiary. I always forget the name of this kind of line. Ternary operator? Ternary? So this is good. So you can use ands. The only exception to that rule is the ternary operator. So you would say something like that. Interesting. I always forget if it's even necessary to do a ternary operator. I guess they would have to be equals direction. So equals true if direction greater than 0, else false, like that. I wonder if, like, I'm just curious if that in itself would be okay. Is that compilable? Well, that's the player. Whoops. Game. So it's kind of backwards. And that's true. Yeah, that doesn't look great. Yeah, I think not doing a tertiary operator is fine. Let's go back to where we were. Just go back a line just so I could see what he wrote. So if direction is greater than 0, I made it sprite d dot flip h equals false. Elif direction greater than 0. I made sprite d dot flip h equals true. Okay. Again, I did the wrong scene. Is pressing this go into the right scene? Yeah. Yeah. So all Gucci there.
To true. And now if we play this, we can see that our player sprite indeed faces the right direction. Now let's add some animation. So let's go to 2D view, select our animated sprite, and let's add 2 new animations. One called run and one for jumping. In our run animation, I'll add some new sprite frames. Select our knight. Remember, this is 8x8, and I'll simply add all of the frames in the run animation, which stretches over 2 lines here. I'll add those frames, set the FPS to 10, and play.
Hold on. So his is 8x8. Why did that reset? That's weird. Ugh. go.
All of the frames in the run animation, which stretches over 2 lines here. I'll add those frames, set the FPS to 10, and play. Look.
Then we play. Nice.
Looks good. Then for the jump animation, I'll also add a sprite frame. And there are a bunch of different ways to go about this. But in our case...
So how does he add a sprite frame?
One called run. And...
So he does do something like that. Oops. Jump. Yeah, you also recommended all lowercase, so let's just rename this to run with the lowercase. So jump, like that, night. So it's weird that it resets
one
though.
For jumping. In our run
I don't
animation,
get why
I'll
the
add some
vertical and
sprite
horizontal
frames. Select our
sprite
night.
frames.
Remember, this is 8x8, and I'll simply add all of the frames.
It's weird that
in
that
the run.
doesn't save. That's kind of annoying, honestly. Oops, not 48, just 8.
Animation, which stretches over 2 lines. Play. Actually play our jump animation whenever we're just in the air. This means that this will also play when we're just falling off a platform. And for this we could use a very quick looping animation or simply a single frame. I actually like this one from the roll animation, so I'm just going to use that.
Yeah.
Then in our script we can of course play these animations. So after we get the input direction and flip the sprite, let's add a new segment which is going to play animations. And here we also need to check our direction variable. More specifically, if our direction is equal to 0, well then we're standing still. And we can go ahead and play animated sprite dot play the animation called idle. If this is not the case, so else, well then we want to play animated sprite dot play the run animation. And that's actually it. If we now start running, we can see our run animation being played. Finally, we just need to add our jump animation.
So let's see, did we get that working as well? Oh. Okay, I feel like my thing, the idle is weird. But it looks fine.
And here we can use a built-in function of our character body 2D, which is to check if we are standing on the floor. So at the top here, we'll check if we're currently on the floor, is on floor. Well, then we want to go ahead and play our idle or run. So I'll cut this using Control X, paste it in here, make sure you tab in. And if we are not standing on the floor, well, then we're in the air and we can go and play animated sprite.play our jump animation instead. So if we're on the floor and our direction is 0, well then we're playing idle. If it's not 0, well then we're playing run. And if we're not on the floor, we aren't doing any of those things, we're just playing the jump animation. And that's it. Now if we play, we have a fully animated knight. I like to think that she's a former princess who got so tired of waiting to be saved from the big bad dragon that she took matters into her own hands. Who better to save some princesses from a dragon than someone who knows dragons like her own back pocket? But feel free to make up your own story. And that reminds me, story. We need a good way of communicating story, hints, and other valuable information to the player. And to do this, we need text. So let's add some text elements to our game. Text. There are multiple ways of working with text in Godot, as part of a larger UI or as an integrated part of the game world. For this game, I decided to try making the text part of our world. In Godot, a text node is called a label. So let's add one. Let's hit Ctrl A and search for a label. Let's focus on it. And as you can see, this creates kind of a bounding box for our text. So I'm going to put it over here and scale it up a bit. And let's add some text in the field here. I'm going to put in a gameplay hint. And as you can see, the text looks really blurry. That's because since we're using pixel art, we're actually zoomed in really far, which makes the otherwise smooth text appear blurry. So we can fix this by...
I remember this was in the other tutorial that they gave us in the Godot documentation. on how to fix how that looks. I don't know if it's under theme or something. We'll have to see what he says.
By using a pixelated font with hard edges to match our style.
Ah,
I've of
never
course
mind.
included some in the assets. So let's go under theme overrides on our label, fonts, and here we can drag in the pixel operator font. We can also change the font size under font sizes here, enable that, and I'm going to set mine to 8.
Okay, hold on. Font. Which one did he do? Shit.
Size under font. We can drag in the pixel operator font. We can also change the font size under font sizes here, enable that, and I'm going to set mine to 8. Note that we have to use multiples of 8 in order for the text to appear crisp. So you can see if I change this to 9, it becomes blurry again. But we can use 16, 24, 32, and so on. I'm also going to go to the colors here and change the font color using the color picker. And now we can place these text elements around our game to provide story or gameplay tips. Once we're happy, we can categorize all of them under a node. So let's create a node, call it labels, and drag all of them under that. And now when we play, as you can see, they appear as a natural part of our game world. And just like with sprites, because the player character has a greater Z index, it will draw on top. So let's use one of these text elements to display our current score. Score and points. To create a score or coin counter for our game, we need two things: a script that keeps track of our current score and a label to display it. It's common practice to place game-wide variables such as a score inside some kind of game manager. So let's make one. We'll hit Ctrl A to add a new node. Let's rename it Game Manager, and I'll place it right at the top here. The reason why we are using a regular node and not a node 2D is because we don't need our game manager to have a transform, in other words, a position, rotation, and scale. Now let's add a script to our game manager. We'll use the empty template, and for the path here, let's put it inside of our scripts folder, and let's also rename it with non-capital letters. Create, and let's create a variable for our current score. So we'll write var for variable, name it score, and default it to 0. Now, so far in our code, we've only used the built-in functions of Godot, and some that we made with signals. In this case here, we want to create our own function that adds a point to our score and displays it. So I'll write func for a function. We'll name it add point, open and close some parentheses, and put a colon. Then on a new line, we'll write score plus equals 1 to increase our score by 1, and print our current score. Now, unlike...
So is score plus plus a thing? No. Okay.
ready, which runs at the start of our game, and our signal functions, which run when a signal gets triggered, this function currently has nothing that calls it. So right now our function is here, but it isn't being run. To change this, we need to go into our coin script and tell it to call this function whenever a coin is picked up. So inside of our coin script, we need a reference to our game manager. But if we just click and drag while holding down Control, we get this really weird looking path. This is because the game manager is higher up in the tree than the coins. And it's generally bad practice to use paths like this that try to access nodes at the same level or higher in the tree. Luckily, because our game manager is a one-of-a-kind and we are sure that there will always be only one game manager, we can solve this by marking it as unique. So let's right-click our game manager and select Access as Unique Name. As you can see, this creates a percentage icon next to the game manager, letting us know that it's a unique node. This makes it much easier and safer to get a reference to the game manager, because now when we drag it in, instead of a $sign with a weird and unpredictable because now when we
So I don't know, what's interesting, because like I want to be in the game and I get the game manager here, but I guess then you click coin. Okay. Like that. Okay.
Drag it in, instead of a $sign with a weird and unpredictable path, we get a percentage sign, which means that
I also wonder, Like, can you make these things like automatically spawn when you open when you're in a specific level? Like, does it have to kind of exist in the scene? I guess it's the same thing as like you kind of manually have to add it as like part of like a game mode, just using Unreal terminology. That's just like, I guess it's not really an object, but you know, it's in the level by default, so maybe you just have to do it yourself.
Godot quickly finds the node via its unique name instead of using a path. One limitation of this is that you can only access unique nodes from within the same scene. If the game manager and the coins were in different scenes, this wouldn't work. Now in our function, we can replace the print line here with game manager, access our game manager, and call the function add point. And now when a body enters our coin, it's going to go to the game manager and run our add point function. And if we play, we can see that every time we pick up a coin, it increases and prints our score in the output window. Finally, we can use what we learned about labels in the previous chapter to create one for displaying our coins. I'm going to make a little place for this in our level.
Cool.
For now, I'll just put in some text that says you collected X amount of coins. I'm also going to change the auto wrap mode to word. Now we can wrap our text and the horizontal alignment to center. Finally, I'll use a bolder font. Now we can take this label and rename it to something like score label. And since we want to change it from our game manager, let's drag it right under our game manager. Now in our script, we get a reference by clicking and dragging, holding down Control. And instead of printing our score, we'll go into our score label and access the text property and change it to you collected. And then
okay. Ba, ba, ba. So something along the lines of that, and then 2D score label, theme overrides, fonts. He made it bold. I guess I could just put it there to whatever.
Here I'm going to add the number, add the score onto that amount of coins. Notice how I make sure to add spaces between the words. And while this looks good, it's actually going to give us an error. And that's because we need to change this score here from a whole number variable called an integer into a text variable called a string. Again, we'll talk much more about variables in our video on GDScript. But for now, we can cast this using str for string and then wrapping it in parentheses.
Okay, simple enough. Like, I'm always kind of curious too if you can kind of make a variable in here, because like in Unreal you can make a formatted text where you do something like, you know, something like that, and then you can basically use score as the input variable, so you don't really have to change the entire text, you just change the variable. Now, is there anything like that? Text stops. No. Maybe there is, I just don't know about it. So congratulations. We've collected like that.
And now when we play and pick up some coins along the way here, once we get to the end, it says, great job, you collected 6 coins. And if I pick up another one,
I see 2
it's
coins.
going to update to 7. Awesome. And I don't know about you, this is great and all, but I think it's distinctly lacking a bling sound when we pick up.
So we got 3 coins there, so that's cool.
Bling, bling, bling.
So that works. Cool beans, cool beans.
Bling. Audio. One of the things that often get overlooked when making a game is audio, but music and sound effects are a huge part of building the mood of your game. This is of course a beginner's tutorial, but let's at least get our feet wet, or should I say our ears wet? Nope, I shouldn't. Let's at least add a music track and a pickup sound for our coins. Now in the assets, I've included a music track as well as a few sounds. And to play these, we need a new type of node, the audio stream player. So let's add a new node, search for audio stream player 2D. Let's rename this to music. Then we can take our music track here, time for adventure.
Okay, so add child node, music.
To music for audio stream player 2D. Let's rename this to music. Then we can take our music track here, time for adventure, and drag it into the stream slot. We're also going to set it to autoplay. And by default, this is not going to loop. To change that, let's double click it. This is going to open up our audio importer. Here we can preview our music track. Groovy. Anyways, we can loop. So let's enable loop here and hit re.
Wait, what?
Now, anyways, we preview our music track. This is going to, and by default, this is not going to loop. To change that, let's double click it. This is going to open up our audio importer.
So it's like that.
Here we can preview our music track.
It's weird that you don't get to do it by default over here, though. They have the settings explicitly
Anyways,
over there.
We can loop. So let's enable loop here and hit re-import. Now, by default, all sounds are played fairly loud, and since this is background music, we probably want to turn it down a bit. We can do this by adjusting
attenuation
the
and
volume on
distance
each individual audio stream player, or we can use the audio tab here at the bottom. This is actually a fully functioning audio mixer, and we can add different buses to control our audio. Let's add two, one for our music, as well as one for sound effects. And then we can simply route our music here into our music bus. So now we can control the volume of our music using this slider. I'm just going to set it to -12. And we have music.
Okay, then bus, music.
Slider. I'm just going to set it to -12. And we have
Where does he set the -12 though?
for our music using this slider.
Well,
I'm just going to set it to -12. And we have music. Unfortunately, it's going to restart whenever our scene is reloaded. A quick fix for this is to take our music node and make it into a scene. So I'll click and drag it into our scenes folder, hit save, and then we can add this scene as an auto load. Auto loads are global scenes and scripts that we want to persist throughout our entire game, no matter which scene is currently loaded.
So that's interesting. So, like, wouldn't you want to do that for like a game manager as well? Not just the
Let's
music?
remove music here from our game scene and instead go to Project, Project Settings, Auto Load. We'll click the little folder here and navigate to our music scene and hit Add. We've now registered our music scene as an auto load, which means that if we now play, even though our music scene isn't in our game, it automatically loads and starts playing our track.
Okay, so did that work? Yes. You can't really hear it, but it's there. That's cool. Okay.
And even better, it doesn't reset when our game restarts. Now to add a pickup sound, we go to our coin and add an audio stream player. Let's rename this to pick up sound, drag in our coin sound, and set the bus here to sound effects. And now we can actually play this sound through script. But since we are removing the coin immediately by calling the Q.
Hold on.
Let's rename this to pick up sound, drag in our coin sound, and set the bus here to sound effects. And now we can actually play this sound through script. But since we are removing the coin immediately by calling the Let's rename this to pick up sound, drag in our coin sound, and set the bus here to sound effects. And now we can actually play this sound through script. But since we are removing the coin immediately by calling the Q free function, the sound won't actually get a chance to play. We can of course fix this by adding code that waits until the sound has finished playing, but then we might get weird functionality where we try to pick up the coin multiple times while it's playing, and it will still be visible until the sound is finished. So let me show you a really cool trick to get around tricky timing things like this without writing any code. That is using an animation player. So let's add an animation player. And here we'll create a new pickup animation. And the first thing that we want to do when we pick up the coin is to hide the coin sprite. So I'll go into the animated sprite 2D, and this will change the window. So I'll go back to animation here. And now under visibility, I get to keyframe the visible property.
All right, hold on. I'm missing something, right?
And here we'll create a new pickup animation. And the first thing that we want to do when we pick up the coin is to hide the coin sprite. So I'll go into the animated sprite.
Okay, so this is kind of like a timeline, I suppose, in Blueprints.
2D. And this will change the window. So I'll go back to animation here. And now under visibility, I get to keyframe the visible property. Now, when working with animations that don't need to play until later in the game, it's nice to be able to go back to the default values after animating. By default here, our coin should be visible. Now, this is pretty cool. If I just create a keyframe here for the default value, Godot is going to ask to create a reset track. If we say yes to this, Godot is automatically going to create another animation track called reset that will simply reset this value to its default state. So now in our pickup animation, we can keyframe it to whatever we want. In our case, when we pick up the coin, we want it not to be visible. So I'll disable that, keyframe it. And then if we want to go back to our default values, we simply go to our reset track, and there it is. It goes back to default. So let's go to our pickup. Let's also modify our collision shape. We don't want to be able to collide with it while it's playing the sound. So let's simply go ahead and add a default key here for the disabled property. Hit create. And now we can set disable to true and add a new key. We can also go into our pickup sound here. And let's add a default key for the playing property. Let's hit create. And now since the sound plays pretty quickly, I can actually reach the key in time. So we can go down here instead. I'm just going to scale this up a bit. Go down here to the value, the keyframe here, and change it to on. So we can actually modify the keyframes here as well. So now we have our pickup animation, and if we go to reset, we can see that everything goes.
Hold on. What?
Instead, I'm just going to scale this up a bit. And now since the sound plays pretty quickly, I can actually reach the key in time. So we can go down here instead. I'm just going to scale this up a bit. Go down here to the value, the keyframe here, and change it to on. So we can actually modify to the value, the keyframe here, and change it to on. So we can actually modify the keyframe.
I gotta see what he's doing. I'm missing this like 100 times.
You can go down here instead. I'm just gonna scale this up a bit. Go down here to the value, the keyframe here, and change it to on. So we can actually modify the keyframes here as well. So now we have our pickup animation, and if we go to reset, we can see that everything goes back to default. So that's just a nice way of working with animation. So now we play the sound, disable the collider, and hide the sprite. After 1 second though, we can go ahead and remove the coin from our scene. So all of these keyframes here are on second 1. Let's put them over to right at the beginning of our animation at second 0. And then after 1 second here, we want to remove our coin. And this is a really cool part about the animation system, is that we can actually add another track here, a call method track that is used to calling functions. So on our coin, we want to call a function, and I'll right click right where we want to do that, insert key, and the function that we want to call is the queue_free method, which is right here. And so now after 1 second, it's going to call the queue_free method on our coin without us writing any code. And voila, all the things we could have done through code are all inside this animation. And again, to get back, we simply choose reset. Now all that is left is playing the animation through script. So in our script, we'll get a reference to our animation player. And then instead of directly calling queue_free, we'll go animation player.play pickup. And if we play now, we can hear our music, and we can hear our pickup sound when we run into the coins.
Okay,
awesome.
That makes sense.
Export! Finally, we are
Yeah,
ready.
exporting is gonna be important. I want to learn how to be able to package and cook these kind of things anyway. Awesome. Whoop, died. Wah, wah. Okay.
Ready to export. Really incredible that you made it this far. You can feel very proud. So let's get our game out of Godot so we can share it with others. Godot can of course export to many different platforms, but I'm on a Windows computer here, so let's go ahead and make a quick Windows build. The first time we are exporting
So
our game, we need to download the export templates. These are a little large, so to keep Godot lightweight, they aren't included by default. To
Okay.
install them, we go to Editor, Manage Export Templates, and hit Download and Install. And the export templates are installed and ready to be used, so we'll close, go to Project, and Export. In this
Okay, so we gotta wait for that to go. Cool. But yeah, I'm kind of glad we got through the rest of this tutorial. I'm in the purgatory of like how much tutorials I should watch before I try to jump in. Because there is one other hour-ish long GD script specific one that I want to watch from Brackeys. Before I attempt to try to make something completely on my own. I already have a game project I want to work on. For those that didn't watch the last stream that I did for Godot stuff, basically I have my Project Echo game design document where I'm gonna have to update it more based off this MassFlux design document. I'm gonna use that as a template. We're gonna write this out. I think I'm gonna try my best to be as good of a game designer as I can, at least with documenting stuff, doing kind of one pagers, trying to figure things out. But the basic idea is to have a platformer game. I'm going to stick with 2D for now, at least for the prototypes, where you can't really see anything. I don't know what the art style is going to look like or anything like that, but perception is going to be a good reference, where basically you use sound to kind of gauge and visualize what the environment is, and you try to avoid obstacles and enemies using sound. So there could be things in sound, like in the environment, that make sound that kind of help you tell you where things are. I kind of want to play around with the idea with the player character having some sort of fear level that would then kind of translate to her being able to make sounds and scream, for example, and her screams provide this echo relocation, and you can kind of see things for extended periods of time or something like that. And you basically have a very basic move set. I want to have kind of that simple mechanic. See how far I could take it with different maybe potential power-ups. Try to flip things on its head with that mechanic. Have enemies that work in different ways, like maybe completely silent enemies, or enemies that respond to your sound. So as you're moving, they'll know where you are, so you have to stay quiet or use distractions to get around the environment and kind of solve these puzzle-esque platforming rooms and challenges and stuff like that. So that's going to be the basic idea. We're going to kind of, once we're comfortable with Godot a little bit more, we're also going to continue this design document, maybe make some one-pagers, and kind of just go through it in what I believe to be the correct way, because a lot of the times when I'm developing games or features, primarily features, just because I'm in the AAA space, I'm not making full-fledged games on my own. But when I'm making features and mechanics, I kind of focus more on, putting something in the game and seeing it from there. Obviously you have to have an idea and kind of break it down a little bit before you even do that. But I struggle a little bit with like paper design, one-pager design, trying to figure out and answer these questions before prototyping anything. I'm more on the side of, let me get something playable, and as I'm developing it, I can ask myself questions and kind of design it that way. And I think that's good for when you're a solo developer, when you're working with a team with other designers and other programmers and stuff like that. It's good to have something solidified, written down, one-pagers that you kind have something to kind of reflect on as your source of truth, and you kind of iterate from there. But a lot of the times, at least what I've been working on, I'm the designer and also like the primary implementer, at least with the blueprint scripts, with the prototypes and stuff like that. So I never find the need to kind of write things down so explicitly in order to kind of sell the vision to somebody else that would then help me kind of develop the feature. I still haven't messed with making design docs, but I've heard they are helpful. Yeah, they need to be, they are helpful. It's always good to kind of go back and be able to reflect and look at something written on paper. And if you do the design documentation correctly, maybe, depending on how you do your documentation, if it's like, one pagers, or if it's like a Miro board, a vision board, something like that, maybe you'll be able to kind of see the thought process kind of written down as well. Like a lot of the times when I'm writing any sort of documentation, there's Confluence documentation, which is more kind of structured, written documentation, broke up into sections and stuff like that. But when I'm initially prototyping stuff and initial design documentation, one pagers and stuff, I kind of, when we work in Miro, for example, I just create these white boxes and I kind of just structure my thoughts into different boxes. So I'd be like, okay, this is, how one part of the feature works. This is how the other part works. This is how it works with this other feature. This is, how it does this and that's that. It just helps me compartmentalize my thoughts, and hopefully it makes things, easier to understand for myself and probably for others, because, I have to take into account, when I make features, how I want debugging to look like what needs to be available when debugging, what information needs to be there to help us track down bugs in the most efficient way. I need to know, I have to ask myself questions. That's usually a separate box, like open questions, like how should this work? Does this really need to go like this? Does it have to go like that? That's just how I work, and I kind of made myself comfortable with that. So I don't want to escape that comfort, but I kind of want to do more. I don't know. I just want to be more, not conscious, but more intentful with the design before trying to implement something. But I'm always the person that wants to kind of jump into a prototype, and I want to make myself a better game designer, in the sense that I want to be able to make my documentation better, make my ideas more clear and stuff like that. All right, so after that little speech, we have everything installed.
And the export templates are installed and ready to be used, so we'll close, go to Project and Export. In this window, we'll add a build platform, so let's go Add, Windows Desktop. We'll enable Embed PCK, which will export it into a single file. Then we scroll down. As for the product name here, I'm going to type in Princess Dragon Slayer, and we can hit Export Project. I'm simply going to put this on my desktop, uncheck Export with Debug, and hit Save.
Okay, Export Project. So there is Export with Debug. So I guess that's also like the different kind of export builds that you can do in Unreal. So you can do like development, shipping, tests, and stuff like that. And then depending on what you do, different things are kind of available. Where did he put this?
To put this on my desktop, uncheck Export with Debug and hit Save. This warning is not a problem. We'll hit OK. And now on the desktop, we have this first game.
Okay, failed to copy export template. Did I forget something? Let's see. So export project. So
this warning, put this on my desk layer. As for the embed PC window, we'll add a build platform. So let's go Add, Windows Desktop. We'll enable Embed PCK, which will export it into a single file. Then we scroll down. As for the product name here, I'm going to type in Princess Dragon Slayer. And we can hit Export Project. I'm simply going to put this on my desktop. Uncheck Export with Debug.
Yeah, so it fails. Interesting. Let's close. Let's see.
And hit.
Let's see. Godot. Partial export thing. So what's constant? This error during the export process equal to unknown. There is an issue with accessing or modifying the export templates. So did I mess up the export template? So editor, manage export templates. Oh, they seem to be okay. So 4.2.2 stable, yeah. Check permissions. Okay, so this doesn't help me too much. Maybe Reddit will know. What the error says, you're missing paths pointing to your export template. So see the empty debug and release paths under custom template section. Let's see, debug, no, is it editor? No, project, export, right? Yeah. So export path, runnable, resources, features, description, options. So debug and release. So that's a custom template. I don't want to use a custom template, right? Oh, okay, so that's frustrating. Let's see. So forums. So I'm fairly certain I did that right? Editor, or no, debug, or is it editor? Editor and manage export templates, right? I mean, can I just copy that? So current version is that. Debug, project, export. Still no. So template file not found. Do I have to give explicit permissions? I know that was like one of the potential things. Like, how do I give the permission? So it says it might be running. Let's save and quit. So like run as administrator. Godot. Really? Manual copy. I mean, what did he do in this tutorial actually?
Save. Add Windows Desktop and the export templates export templates and hit download and install. And the export templates are installed and ready to be used, so we'll close.
So his is also an app data, so that's weird.
Go to project and export. In this window, we'll add a build platform, so let's go add Windows Desktop. We'll enable embed PCK, which will export it into a single file. Then we scroll down. As for the product name here, I'm going to type in Princess Dragon Slayer. And we can hit export project. I'm simply going to put this on my desktop. Uncheck export with debug and hit save. This warning is not a problem, we'll hit OK. And now on the desktop, we have this first game.exe. We can open that up.
So, yeah, that doesn't work. Cool. Does anyone else have issues with the... Re-downloading templates. So failed to open first game temp. I mean, is that happening the whole time? Like, what's going on here? Project, export project. Yeah, so it does both. So failed to open. So let's see, Godot. Failed to open. Or just .temp. No. What could this be? So here's the export path. Okay, wait. Now, was it because, wait, huh? Was it because of the path? Do I have an exe somewhere? That's weird. Maybe I just didn't have permission? Yeah. Ah, dead. Rip to the goat. Okay. Simple enough.
And voila! We made a game! Woohoo! And that's it! Congratulations on making your first dish, or I mean, game in Godot. If you don't understand everything or are unsure about where to go from here, don't worry. That's totally normal. It takes a little while to become familiar enough with the tools to feel really free with them. Never hesitate to use the documentation, tutorials, or code examples you find online. When I started out, I spent a lot of time remixing other people's scripts before I started to write my own. Now, where do you go from here? Well, that's totally up to you, but if you want to continue adding to this game, here's a list of things that you can try out. Expand the level. See how far you can get using just what you know now. I think you'd be surprised with how much fun gameplay you can get out of just these simple elements. Add effects, like an animation or particles when picking up a coin, or more sound and music. Add more danger elements like spikes or traps that turn on and off. Most of these are just variations on the kill zone we've already made. Add a main menu, more enemies, give the player a weapon or add power-ups. You can also expand on the game manager, for example to use it to switch scenes. A common way to do this is by turning it into an auto load, just like we did with our music track.
Okay, so that's what we thought,
right? Or perhaps you want to improve player movement by adding coyote time and double jumps. The possibilities are endless.
What the fuck
also,
is coyote
don't forget to
time?
check out Zenva Academy. Be among the first 50 people to use the coupon.
Oh. That's interesting. Yeah, I would definitely want to do Coyote Time for my project to have that little bit of leeway, I suppose, when running off of things. So I'll have to learn how to do that too. But yeah, I don't know explicitly, like, you know, I have to kind of do that with the design documentation. I talk about like player movement and things like that. But that'll be kind of interesting to figure out, I think. So yeah, that's this tutorial. So next we're gonna watch GD script, but we'll save that for next time. So we'll kind of leave this queued on my machine here. But yeah, I think we've streamed enough for today. So yeah, I'm most likely going to stream tomorrow. I think I'll do more Godot tomorrow rather than doing more Unreal. We managed to get a good amount done for Unreal. Last time I got the update writer for a little bit, but I managed to do some fixes with how I'm doing damage and replicating the damage. I just have to clean up a couple things. Like, we were finally able to fix what we were doing. I don't know why it just opened this window like that. That's weird. Go back. Figure out how to properly do the damage. There's definitely an issue with trying to, when you replicate, trying to get the get component by class function. It's just not returning correctly in multiplayer. But we were able to get that. So basically what I want to do to end the whole damage and health, because I was implementing, what's that thing called? View models for setting up the health and everything like that. I think there's still a good amount happening in in blueprints in the component that I want to get rid of. Like, there's all of this, like, listeners and stuff like that. I want to translate this into C++, so this is all handled there, rather than in Blueprint, obviously. But yeah, just to give a preview of what we're working with. We have health now working, and damage working in a replicated environment. So we have the server on the right, client on the left. Everyone's able to do damage, and we're able to deal damage to each other. Whether or not we want to do that, up for debate, but something we can figure out later. It's good that it just kind of works. We could have friendly fire or something like that. And we have burn, status damage, all that stuff. So yeah, maybe we'll work on that on Tuesday to do the part of the final cleanup. I don't think I'll be able to do this in one stream just because I'm not that good. But yeah, once we can finally fix that, we'll start looking at that free motion matching implementation project that they gave, so we can update our characters' kind of movement and stuff. Because I want to start introducing like strafing. Because yeah, we have like the forward movement and stuff, and it's kind of slidey, and I kind of want to introduce the whole provided thing here. So curious why when I press X it automatically applies burn. I must have put something there. So we gotta figure that out. I guess while I'm here, I think I must have added something, right? Player, is it in here? Sorry for getting sidetracked here. Is it in this character? No, it's not in this character. It's in the elf. So that applies damage, that applies heal. Let me find the burn. Burn full, reference, viewer. Oh yeah, I probably put it here, right? Yeah. So we can put that back. So yeah, now it's back to normal, and we have aim assist, where it'll generally try to target the correct selection here and get that going. So yeah, we'll continue this project on Tuesday, I think, this example project that we want to work on. So yeah, thanks again for watching. I appreciate it. Squeaky Knee, thank you so much for the sub and the follow, and thanks for chatting and hanging out. If there's anyone else watching that isn't already following, a follow would be much appreciated. There is a handful of people watching, so I think we'll do a raid, just to raid somebody, you know. So we'll raid Cadamilla. So yeah, enjoy the rest of your night, guys. We'll try to stream tomorrow as well as on Tuesday, and we'll see what other days of the week we could do it as well. Take care. See you soon.